Okay, this is kind of a derivation from my master's project. Okay, so when we use spin calculations, we have two options basically. Either spin polarization is negligible, which means we don't have magnetism, or it's important, which would be magnetic. So what we're studying is the single dopant and the dual dopant, and you can't really see with the colors too well, but so here, nickel, we have a single dopant, and this one, we have it on the top and bottom surfaces, and then these are, each top and bottom surface is covered with 4 water molecules. So here's the density of states for the single dopant. And for the normal one, we see these added states. Normally, titanium will go from -2 to 0 as the band gap. It's obviously computed a little smaller, known from DFT method. And then when we do the spin polarization, we see these added states again, but we also see they have complete equal occupation. So we're not seeing any difference from spin up to spin down. So when we do this with 2 dopants, we would expect the exact same thing to happen. However, for some reason, so we have double the number of added states, so we go from 5 to 10. But here we're seeing these states are different in the up and down things. They're not equal of energy. And so just to put it in a little perspective, here's the Excel sheets, and we see the single dopant overlaps each other, and the dual dopant does not, especially around HOMO-LUMO, which just adds more questions than answers. So we need to, and then here's some absorption spectrum. We see the dual dopants. They have the same number of general peaks, but we just see a little bit shift in them. I didn't get to analyze this, and sorry, this is actually in nanometers for both of these, not electron volts. And then here's the quick geometry optimization. This is for the single dopant, and it was actually, we usually compare these to the undoped models, so this was pre-optimized with just titanium, and then after the dopant it was re-optimized, which is why you're not seeing much movement. So in conclusion, we know that spin polarization is important, but the dual dopant and single dopant need to be studied further, because I honestly can't think of a chemical reason why the single dopant would not be magnetized and the dual dopant would when we're dealing with even number of electrons. So this would, I think, indicates low spin nickel, which is quite rare in this octahedral complex from what my short research that I was able to do last night. So, so we need to do a little bit more analysis. And then we also need to do spin polarized advanced calculations, because the real thing is this spin polarization going to affect the electron hole relaxation rates? Because that's our main goal, is we're going to look at how the charge is transferring through these molecules. And if the spin doesn't affect that, then we can just neglect it and not have to deal with the advanced calculations. So that's all I have.